Okay guys, today we're going to put solving quadratics all together. So far we've learned different ways on how to solve a quadratic. We've done it by graphing, we've done it by factoring or the tic-tac-toe method, and we've done it using the quadratic formula. That was that long fraction formula. Okay, so we learned all these different ways, and all of them, no matter which way we did it, it was asking us to find the solutions. So let's clarify really what we were finding. Well, solutions, guys. Another word for solution are the x-intercepts. You might hear it called roots. Or zeros. Okay, all of these words mean the same thing. So no matter which way I was doing it, what I was looking for is, when it asked me to find the solution, is where does my parabola cross the x-axis? And we had three possibilities for that. Okay, so let's say that this is my x and y axis. I could have a parabola that crosses the x-axis twice. I could have a parabola that only touches the x-axis in one spot. Or I could have a parabola that never ever even touches the x-axis. So this first one is when we would have two answers separated by a comma. This is when we would only have one, and this is when we would put no solution because it never touches the x-axis. Okay, so you can use any of these methods to solve a quadratic. Graphing will always work. The quadratic formula will always work. Factoring, sometimes you're going to get an equation that's unfactorable. But keep in mind that graphing and the quadratic formula will always work. Okay, so now what we're about to do is we're going to do the same equation, and I'm going to do it all three different ways, and then you'll be able to see that no matter which way I chose, I'm going to get the same answer because I'm going to be finding where it crosses the x-axis. Okay, so here's my equation, 2x squared minus 5x equals 12, and I'm going to do this by graphing. Well, no matter which way we decide to do it, it's very important to check that it's set equal to 0, and right now it's set equal to 12, which I don't like. So to make 12 equal 0, I'm going to do the opposite. And the opposite of a positive 12 is a negative 12. So I'm going to take away 12. What I do on one side, I do on the other. My positive 12 and my negative 12 cancel, so now it's set equal to 0, which is what I wanted. Okay, but on this side, I have x squareds, x's, and then constants, regular numbers. They're all different, which means I cannot combine them. So I'm going to rewrite it as 2x squared minus 5x minus 12. Okay, so now that it's set equal to 0, I'm going to take my equation and I'm going to go graph it. Okay, so guys, I know that a lot of you didn't have the Inspire software downloaded, so I'm going to go to a website that anybody can use as long as you have access to the internet. So in my browser, I'm going to go to desmos.com and I'm going to start graphing. Okay, you see this keyboard right here? I'm going to click it because it's going to help me enter. Okay, so I'm going to enter what our equation, the one that was set equal to 0. Okay, and we said it was 2x squared minus 5x minus 12. Okay, and I'm going to close this down so I could see. All right, so here's my graph. This is 2x squared minus 5x minus 12. So we're finding the solutions. We're finding the x-intercepts. So here's my x-axis, and I can look where it crosses the x. It crosses here, so I'm going to click on that. So I know it crosses at negative 1.5, but it also crosses over here, so I'm going to click on this as well. It crosses at 4. So I know I have two answers because it crosses the x-axis twice, negative 1.5, and it also crosses at 4. So those are my solutions, my x-intercepts, my roots, my zeros. Okay, so that's how you do it by graphing. In my opinion, that's the easiest version. All right, so I'm going to take the same exact equation, but this time I'm going to solve it by factoring. So remember, it doesn't matter which one we decide to go with. We have to make sure it's set equal to 0. Okay, it's the same problem. We just did this. Remember, we took 12 away from both sides. And that gave me 2x squared minus 5x minus 12 is equal to 0. Okay, and I'm going to go ahead and tic-tac-toe. And these are what we're going to use tic-tac-toe to find our factors. So we put our first and our last. So I'm going to tic-tac-toe this guy right here, my first and my last, so 2x squared, 12. And remember, we put our middle term, including the sign here at the bottom. Okay, this sign right here is a minus sign. Minus literally means difference, so I know my signs will be different, knowing I'm going to have to use one plus sign and one minus sign for my factors. Okay, so I'm going to write my factors of 2x squared. Well, two things I can multiply together to give me 2x squared. Well, that's 2x times x. And my factors of 12. 1 times 12, and I flip-flop. 2 times 6, flip-flop. 3 times 4, and flip-flop. There's only one option here, so I'm going to go ahead and fill that one in, 2x and x. Okay, there's several options here, so I could do trial and error, guys, but just for time's sake, I'm going to help us out. I'm going to try the very last one. I'm going to try 4, 3. All right, remember what we do here is we multiply across. 2x times 4 is 8x. X times 3 is 3x. Keep in mind we said the signs must be different. One has to have a plus, one has to have a minus. Well, to help me figure out which one goes with which, I look down here. I know I want to end up negative, which means I'm going to have more negatives. So I'm going to put my negative with the bigger number. And then I can always check myself. Negative 8 plus 3 does equal negative 5. So I go ahead and I slide my signs over. And then we crisscross. So my first factor is 2x plus 3. Crisscross the other way. My other factor is x minus 4. Okay, so those are what we call the factors, right? So we're trying to find the solutions where it crosses the x-axis. Well, hopefully you remember, in order to find your solutions from your factors, we have to set them equal to 0. So I'm going to take this guy right here, 2x plus 3, and make it equal 0. And I'm also going to take this factor, x minus 4, and set it equal to 0 as well. So to find my solutions, I'm going to have to solve for the x so I can see where it crosses the x-axis. All right, so to get x by itself, I get rid of a plus 3 by taking away 3 on both sides. So it's going to give me 2x equals 0 minus 3 is a negative 3. Then to get rid of this 2, I'm going to divide by 2 on both sides. My 2's cancel, so that gives me x is equal to negative 3 halves. Well, guys, negative 3 halves is the same thing as negative 1.5. All right, so let's go find our other factor. So I'm going to solve for x. To get rid of a negative 4, I add 4. What I do on one side, I do on the other. X drops down, so I have x is equal to 0 plus 4, which is 4. Notice, same exact problem we did before using the graphing calculator. Look at my two answers. These are my answers we got whenever we did it by graphing. They have to be exactly the same, exact same equation. We just did it a different method. So it crosses the x at negative 1.5 and 4. So same equation, just the first time we did it by graphing, this time we did it by factoring. We still, no matter which way we did it, we found where it crossed the x-axis. All right, now let's do it using the quadratic formula. Remember the big, long fraction guy? Okay, so remember, it's always important that it's set equal to 0. That's always your first step, no matter which version you do. All right, so we already did this. We got rid of 12 by subtracting 12 on both sides. And that gave me 2x squared minus 5x minus 12 is equal to 0. Okay, so after we set it equal to 0, to do the quadratic formula, we have to identify our a, our b, and our c value. So I know a is 2, b is a negative 5, and c is a negative 12. All right, so I'm going to plug into this formula. It's one big fraction, so I'm going to put a big fraction bar. Okay, it starts with negative b. I like to think of that as the opposite of our b value. So I look at b. The opposite of a negative 5 is a positive 5. Plus or minus the square root of. Now on the inside, we need to take b and square it. Guys, it's very important to use parentheses inside of here. So I'm going to take my b value, which is negative 5. I'm going to square it. Next it says minus 4 times the a value times the c value. On the denominator, I have 2 times the a value, so that's 2 times 2. All right, so let's go ahead and simplify the top. So on the top, I have 5 plus or minus the square root of, and notice there's a whole bunch of numbers going on in here inside the radical. So what I'm going to do is I'm going to simplify the inside part only, this guy right here that I highlighted. So only the inside. So I'm going to go back to my Desmos calculator. And I don't want to graph it. Let's see. Desmos.com. And I don't want to graph. / calculator, I believe. Maybe I just type it in. Let's see. All right, so I'm going to type in parenthesis, negative 5, close parentheses, squared, minus 4, parenthesis, 2, times negative 12. Close my parentheses. All right, there we go. I did it for us. All right, so I typed only the inside of the radical. And it tells me that it's 121. So all of these numbers on the inside simplify to just 121. On the bottom, let's simplify. 2 times 2 is 4. Okay, so now what I'm going to want to do is I want to see, does the square root of 121 simplify into a nice pretty number? If it does simplify to a nice pretty number, I'll go ahead and simplify. If it gives me an ugly decimal, I'll just leave it in radical form. Okay, so let's type this in to see, is it nice and pretty or not? So I'm going to type this in, including the radical this time. Okay? All right, so square root of 121 is 11. That is a very pretty number, so I can go ahead and simplify. So on top, I'm going to have 5 plus or minus 11 all divided by 4. So remember, if it gave me an ugly decimal, I would have just left it as the square root of 121. But it simplified to a pretty number. Okay, so to find my solutions, to find where it crosses the x-axis, the first time I'm going to do 5 plus 11 divided by 4. So let's go ahead and do that. Well, 5 plus 11 is 16. 16 divided by 4 is 4. All right, this time then we're going to do 5 minus 11. 5 minus 11 divided by 4. Well, 5 minus 11 is negative 6. Negative 6 over 4 reduces to negative 3 halves, which is exactly the same as negative 1.5. So we know our two solutions, it's going to cross the x-axis at negative 1.5 and at 4. Notice, exact same answer as we got the past two times. Boom and boom. Because we were finding the solutions for the same equation. So it doesn't matter which version you use. Do remember that graphing and quadratic formula will always work for you. But it doesn't matter which version you use. Just make sure that the equation is set equal to 0 before you do any method. But just remember, when you're finding the solutions, you can either do it by graphing, by tic-tac-toe, or the quadratic formula. It's just the same stuff, just doing it a different way of getting there. All right? All right, later, guys.